I'd like to introduce Dave Blakey from Snapt. He's the CEO, co-founder. He calls himself a janitor from time to time because he does everything there. And Dave is going to talk to you about Snapt as a software-defined application delivery controller. I don't know too much about it apart from the fact that I really like it. So Dave, thank you very much.
Thank you. Cool. Sounds like it's on. Afternoon, everyone. Thanks for listening in to me for the next amount of time that this presentation will take. We'll work it out as we go. Let's quickly kind of touch on what an ADC is, I guess. I'm sure it'll be a bit repetitive for some of you, but I'll be brief. An ADC is kind of the next step of load balancer. Obviously, largely that's now software, running in a cloud, VM, something like that. But really, it's responsible for directing the traffic to your servers. Use case being, let's say, you start up, you've got one web server, and all your traffic's going there. You reach one of 2 points quite quickly. Either you need two because you don't want one to fail and for it to go offline, or you need two because the load is too great for one. And usually, obviously, this is at the same time. And in most use cases, actually, it's many more than two servers, right? But you get the idea. So you need something, as soon as that happens, it sits in front and says, well, let me put this user on a server that's online. And then you take the next step from there and say, well, what other value can I add? Can I put them on the fastest server, the server most likely to respond the quickest? Can I check what it did respond to them with to make sure it's in line with what we expect to get a response for? It's on an error page, things like that. Can we accelerate that content so it loads faster for the user? And finally, can we protect the servers? So can we have a firewall sitting in front of it? And that kind of line of questioning wound up being what people call an ADC today. So the core kind of functionality in an ADC is primarily HTTP, HTTPS focused. It's looking at load balancing, so performance and reliability, at web acceleration, again, performance, getting the content to users faster, and then security being the WAF. So that's the space in general. Snapt in that space is focused on software solutions, obviously. So we're a software-only product. Many of the people in the market now have software solutions as well, of course, but we focus a lot on what people need in the cloud, performance in the cloud, performance on commodity hardware in the cloud, stuff like that. It's not really, a copy of a hardware solution, if that makes sense. It was built as software. So we've been in business since around 2012. Large US and European presence, more recently investing in South African market, obviously, with partners like this. And growing quite aggressively, but still one of the smaller players in the ADC market. We have quite a large Fortune 500 presence, so about 6 out of the 10 biggest banks run by Snapt. You'll see a list of clients just now, but there's a lot. We'll go through some of them with you. Footprint in 60 countries, and it's built to handle a lot more flexibility in what you expect of an ADC, right? And we'll get into that in a bit more detail soon. So that's kind of where the DevOps angle comes in for us, is when we started developing the product, it was really at the time that DevOps was starting to take off, and not DevOps as a culture like it exists today, but DevOps that people needed solutions that other, hardware solutions weren't built for, that things didn't fit, that needed customizability, scalability, stuff like that. And that's kind of our background. And that's led us to develop this bleeding edge ADC, right? Focus on HTTP, HTTPS data. So people that have got big websites, APIs, internal stuff, anything like that. Obviously, that's kind of our meat and potatoes. So trends in the industry, a lot more data transactions, as you guys will know. I don't know if you'll know quite how much it's growing. I mean, we've got clients now. So when you look at ADCs, for example, it used to be purely north-south. So you would have traffic come into your data center. You would load balance that traffic. And you would often have 1 or 2 ADCs, maybe 4 or 6. We've got clients now that have got 400 in production in one environment. And are looking at scaling to 4,000 in the next 5 years, right? So massive increase in the volume of data that people are seeing, and they need to kind of scale. Need for uninterrupted communications at scale. Scale nowadays means things that are quite different from what it used to mean in the past. Things are not static, right? Like you've got environments like Kubernetes and even cloud native, just plain cloud, where you can, auto scale, spin stuff up, spin stuff in, and so on. So a lot of difference around there. There's a lot more complexity in the ADC industry now. So multi-cloud deployments, microservices, like I mentioned, hyperscale stuff, etc., which we'll talk about a bit. Some examples and how Snapt works with that and what the industry's kind of doing, and compliance and threat management. Those are big kind of focus areas in ADC. So really security and then what we would call modern scale, right? So like scaling out in environments like Amazon or Azure or whatever it might be. So some lighthouse customers, like I mentioned, Snapt is predominantly enterprise focused. So a lot of our customers are big enterprises. But we do quite well in small and medium business as well. The product is quite compelling for them, but the large use cases for us are always obviously large enterprise. So let's have a look at the type of user. This is one of the more exciting kind of things to talk about. So this is the DevOps user, right? And DevOps, it's kind of a funny term for me at least. It's like everybody seems to want to say that something is applicable to DevOps now. But really, to me, I think it means something that's maybe a little bit different from the norm, and that's just from what we see as our user. When we started building Snapt, we just thought, well, let's build an ADC that we need because there isn't an ADC that kind of solves our problems. And it turned out to be very much in line with what this DevOps user needed. It's not just a product thing, it's a business thing, right? So it's from the business model to the way we license, to on-demand licensing, to flexibility. Like this DevOps user today is not, in the old days you would have someone that's a specialist on the load balancer, maybe even a brand name, like an F5 network engineer would be in charge of the F5 device. And now you have a DevOps engineer that's in charge of the web server, the platform it runs on, the AWS account, the load balancers they use, the software they do, the uptime monitoring, the whole shebang, right? And often it's a team. And somewhere in between there is where most businesses find themselves, like migrating towards the more DevOps type style. And it means that they need like something very different. They need a product that's easy to install, easy to ramp up, easy to train people on. They need a product that provides a lot of information post-installation as opposed to pre-installation. So you used to have a set it and forget it mentality with a lot of this type of equipment, not exclusively ADCs even. Like from routers to switches to layer 7 apps to anything, people would often say like, don't log in, like we don't want to break it, like don't change anything, it's working. You need change control for 6 weeks to make a change on a primary load balance and stuff like that. Whereas now, people are responsible for the platform, not just the availability of it. So they're interested in knowing, well, there was a deployment last night, and now this morning the web servers are responding 200 milliseconds slower, and they want to be told on a Slack channel about it. And there's just this huge amount of kind of value add and requirements that people have from platforms like an ADC that didn't exist before. And that's what DevOps means to me. Like a jack of all trades as opposed to a master of a single one, and someone that really wants to get a lot of telemetry information and kind of be using the product on a daily basis as opposed to set it and forget it, like static infrastructure. So we spend a lot of time working with financial services, obviously healthcare, retail, big online presence people, things like that, or people with very critical business information, banking, stuff like that. Pretty much any business size, 10 to 10,000. Instagram had 11 employees, right? You can't really judge a business by employees today, so it's quite varied, but generally speaking, it will be people on closer to the leading edge of the market. Obviously, as you guys all know, is kind of looking into DevOps. We shy away from the more traditional deployments, I guess you would say, and really turn into the more modern ones where people have got unique problems and looking at microservices, hyperscale, stuff like that. So a lot of DevOps focus. Now, here again, just to kind of reiterate, DevOps has really changed the game, like I mentioned, but applications and networks and everything are just not how they were 20 years ago. And the reason I say 20 years ago is because I feel like from 20 years to 5 years ago, there wasn't much change. You get traffic in, you send it to your servers, you get the traffic back, you send it back. I mean, now we've got people that, in production, they could have 5 servers running at midnight. And by midday, they could have 5,000. So, they have these very dynamic loads changing a lot. And that means spinning up a lot of servers. It means spinning up a lot of ADCs. It means being able to handle bursts of traffic. It's just like the state of the game has changed a lot. I was speaking to a client a while ago, a couple months back, that at the launch of one of their new releases, they had 8% of all internet traffic went to their data center, right? 8%. It's like people are having to deal with scaling problems that just didn't exist before, And so it really requires a more modern solution and something that is agile and flexible, etc. And then because of having to scale up for that, people are winding up paying for the costs involved with that, right? So like when you're running 5 servers in AWS or in Azure, you only pay for the 5 servers. When you boot up another 5,000, you pay for the 5,000. But with load balancers, the ADC, static infrastructure like that, you've got to, you have to sit down today and say, okay, cool. I need to make a load balancer purchase that's going to cover me for the next 3 years that we write this thing off over. And it just like, it doesn't, the two markets don't fit anymore. So that's like one of the core kind of components when like people often say, what's different about Snapt? And I often try to say, look, it's not the product. The product is totally different as a result. That's the output from our business being different. But like the input to the business being different is just this very different user. Someone just needs something that the current market didn't address, and that's why we started to address that, right? The output is that the product is very different. So, they need flexibility, they need agility, etc. Is really the point I'm trying to mention. So a lot of young people, obviously 20 to 45 is kind of the biggest gap for us. Looking at highly available services, cloud native, they want to improve performance, reduce total costs, things like that. And another big trend in the market is people are learning about the value of accelerating content to users. Like if that's something that I could kind of impart to people here today, I think I would be quite happy about it. We've got a lot of stats on our website and stuff when you look it up, but really in the old days, web acceleration and caching and all these technologies, they were largely focused on offloading your web servers. So like you had 5 web servers, you simply couldn't have more. So you would try and use some technology to offload like 30% of that load, and that would help the web servers cope better, and you would move on. That's kind of just a standard accepted practice now. The real key is in accelerating the content to the user. And that's also quite a known concept, right? Like, okay, well, the website takes 15 seconds to load. We want it to take 5 seconds to load. So let's speed it up. And it's pretty easy to do that in reality, especially if you have someone that knows what they're doing. What's new now is this need to make a website take 2.5 seconds instead of 3, or from 2.5 seconds to 2.3 seconds, or down to 1 second. It's like micro improvements. And they become really big because some of the big players, even some of the medium-sized players, are starting to realize like the massive improvement this has on buying behavior and user experience and stuff like that. So like as an example, Amazon, they estimate that every 1 second of page loading time on their site costs them just over $1 billion a year for 1 second, right? Now to get $1 billion more revenue, can you imagine how much advertising they have to do? Or they can just shave a second off of their website. And the average website in the US, which to be honest I think is probably faster than here, takes 12 seconds to load. So like when you think about the difference that these guys are aiming for and what your common player has, like there's really quite a large value add that you can get from this kind of technology. And that's one of the more like interesting education type spaces that we deal in, is really how do you shave a website from 3 seconds to 2, from 2 to 1.5, and how do you make sure that people have the best experience? And it's quite nice because a lot of the time you can see like an immediate improvement. Like you deploy it on a medium-sized news site, and they get 20% more ad views. Or you deploy it in front of an e-commerce, like for example, Target is a client of ours. Deploy it in front of their audience, 15% more conversions. And it's from like small changes, that you don't even notice yourself. Google did a test as well. Like how long does a Google page take to load when you do a search? Because anyone ever actually wondered, like it's instant, right? Like if you search for something on Google, you get the result immediately. If it was 33% slower, would you notice? Almost certainly not. Like I wouldn't. I mean, the slowest part of Google loading is probably my internet connection. They slowed a portion of their traffic down by 33%. Just the search result page, 33%, that's all. They didn't add any fixed time or anything. They just slowed 33%. They lost 35% of their ad clicks. Just from like a change you wouldn't notice, So it's quite a big deal. And these are the type of things that a lot of like DevOps people are looking at now, because DevOps people are no longer responsible for the ADC or for the server or for the firewall, but they're responsible for the platform, the system that you run, right? Whether it's email, an intranet, an e-commerce site, a website, an API backend, an app, whatever it might be, like people are now responsible for the whole, and so they start to care about these type of things. And that's the type of person we try to speak to. So how do we go about solving these things? So modern models build around use cases. This is really where I was talking about the business being different, right? So the product, it does all sorts of things, and we'll get into that when you look at the product more. It supports things like Kubernetes, it supports service discovery, can scale out and scale in, and all of these various things. But like the first thing is, well, like how that 200 licenses I was saying at one of our banking clients, how do they run 200 ADCs? How do you buy 200 ADC licenses? Like what is the business model around solving that problem? Especially when some of them aren't used and some of them are used, and sometimes they use 2,000 and sometimes they use 100. You need on-demand pricing, you need different licensing, you need different ways of deploying, you need to be able to automatically deploy and spin things up, and it has to address those kind of problems. So that's like a lot of the things that we're looking at, and problems that we're solving are, how you actually do it in the field as opposed to, the features of the product necessarily. So ease of use and deployment should be very easy to use, spin up. You can get a Snapt trial on our website. It's up and running in 5 minutes, load balancing, all the stuff you need, etc. Also makes it very easy to train staff members, to get team members on board, to give people access to certain pieces that they can see stats, or your developer can see the load times on the website and stuff like that. A lot of flexibility. So every client now, especially when we work with cloud providers, is slightly different. Needs a different API, a different webhook when something happens. Needs to connect in a different way to something, or integrate with a different, CI/CD system or whatever it might be. So a lot of flexibility and customizability. Low impact on business. So one of the funny things you'll see about Snapt, and it shouldn't be funny, but I suppose it is that when we give performance recommendations on our website, it's for 1 core and 2 gig of memory, right? So basic entry-level system in a cloud provider. And the reason for that is because people are running 200 of them or 300 of them. And they're scaling like in a cloud-native way, as opposed to scaling off pure hardware. So competitors will give you 16 cores or 32 cores as a requirement. And people are working out that A, cloud's not that cheap nowadays, and B, that when you have to deploy hundreds of these things, it's just not scalable, So we really look at saying, well, what performance can we get out of commodity hardware? So we offer around 100,000 layer 7 requests a second on 1 core. So, that can be like a pod in Kubernetes. It doesn't have to be a massive cloud instance, for example. And a focus on metrics and performance. So that's what it's saying, like this DevOps kind of mentality, adding value to them after the thing is running, is really saying, well, the page has slowed down. Or, for the last week, or last week Monday, you had 0.1% error rate on your website. Now, this week Monday, you've got 2% error rate on your website. Something's gone wrong, or the service has been degraded, things have slowed down. What 500 errors are coming back? What's the latency and replies from servers? Is the network latency increased to the servers? Maybe it's a cloud provider problem. All of that kind of like data in an effort to be as proactive as possible, right? Because in ADC and load balancing today, the worst case situation is that a server goes offline. Because a lot of the time that means errors are going to leak out, problems are going to happen, etc. Really, the best thing that we can offer is to try and be as proactive as possible. And I think that's very much the DevOps mindset, scaling out proactively, etc. So look at our solution. It's made up of 4 components. I touched on this already, so I won't dawdle on it too much. But you've got the balancer, obviously your layer 7 load balancer. The WAF is providing application firewalling, denial of service prevention, rate limiting, all that kind of stuff. And your accelerator, which is really trying to move that content to the user faster. It does, of course, offload servers, caching, all that kind of stuff. One of the nice things is that it also offers dynamic caching. So a lot of the time people say, oh, caching, I can't cache my website. It's like I'm a news site, CNN, whatever. I can't cache my content. But you can cache for 5 seconds, for example. We had a use case actually in South Africa where someone needed to cache their website for non-logged in users for a very short amount of time. And the reason was to ramp up for a big news story breaking and tons of users come into the site and them not being able to handle that amount of traffic, right? So if you think like of your service, your performance, especially on dynamic content like PHP backend or IIS, whatever it might be, how many requests, actual users requests a second can you process on that server? A lot of the time today we see with clients it can be 100, 200, 300 requests a second and the server's already starting to choke up and feel the load, right? Of a dynamically cached page on the accelerator, again on 1 core, you can respond to about 500,000 requests a second. So it amplifies kind of the reach of your website, the scalability of your website. And it can handle things like the servers being offline and just serving the last page and so on. So for people that are trying to sell a product, that's no good. But for people that are showing ads on their sites or something like that, then you start to say, okay, well, at least my content's still up and so on, and you get a lot of value. And then the GSLV. global server load balancer. So it's just a smart DNS server, basically. It's able to say, all right, send my US users to the US, European users to Europe, but if Europe's down, send them to the US, etc. If you've got co-location hosting, multi-cloud, stuff like that. So we see a lot of multi-cloud today. So you might want to say, I'm either multiple locations in one cloud provider, or I'm in Amazon and Azure, and I need traffic to be load balanced between them, and disaster recovery to be on one side, or even Joburg and Cape Town, whatever you might have. So Snapt in the enterprise, business case and tech needs. We've chatted about a lot of this stuff, so we don't need to go through it in detail. But a lot of the business needs are around reducing the cost of ownership, reducing the risk, increasing revenue, staff ability to manage the devices, ability to use them in the environments, as people move to things like Kubernetes and so on. And then the tech needs are largely around flexibility, both from a business case and a product case, and what it can do, and modern support for things like Amazon is a good example. In Amazon, you can auto-scale servers. So you can say, okay, my web server, when it gets to 70% CPU usage, boot up more web servers. And if it keeps being boot up many more, you can set obviously a limit on that, and you can shut it down. So on a load balancer, you now need to know that there's new servers. So with Snapt, for example, you wouldn't say, load balance to this IP address and this IP address. Instead, you can say load balance to this AMI ID. And then it will look up what Amazon machine images are running, find the AMI you want, see how many servers are running, and then send the traffic to those, right? So a lot more like kind of this dynamic support for just the needs that people have today or are going to have tomorrow. And where do we see ourselves normally deployed? So obviously in cloud, you would normally be behind. It depends on your deployment, but in a big installation, you might be behind their ingress load balancer, right? Their north-south load balancer. And then you would have the two Snapt devices and your web servers, app servers, email, whatever you might want behind those. Pretty traditional, obviously, but also Snapt doesn't have to be in line of traffic, right? So you don't break the network. It's a full proxy, so we don't do direct server return, anything like that. So you can load balance over the internet if you need, but you can just have one port, so it can just be sitting off of a switch. It doesn't have to be in line for you to use it, obviously, which also makes things like redundancy and stuff a lot easier. So technology partnerships and solutions. Some key technology partners. Like I mentioned, a lot of work from us goes into virtualization and cloud platforms, right? So from basic marketplace images with people like Amazon and Microsoft to going high up the stack with them, adding more support for a lot more of their custom features, working with their clients and so on, to a lot of kind of cloud or VM providers, container platforms, things like that. A lot of partnerships with these people to help their clients kind of address the problems that they have when they move onto these platforms, right? So you can imagine someone moves from very traditional into something like Docker Swarm or whatever. There's obviously a need for new vendors, So we work with a lot of them. Case studies. These are nice, to kind of drive home the point. But I think I've covered a lot of this already. But basically, what you've got are people's pain points and what ultimately the results they wanted were. So in this example, we've got a managed service provider for 3 out of the 10 biggest banks in the US. And they had problems with meeting uptime and SLA requirements, high availability requirements, PCI compliance, things like that. And then a very high cost of deploying in a microservice architecture with competitors. So with microservices, you've got, perhaps I can even touch on this. What we've seen in the past, and this is outside of Snapt even, is that people will have a very expensive load balancer, tin one usually, hardware, right? And then that's very static. So what you start to have is like one of two problems. Either the first is that you need to use it for something. Like let's take like a DevOps type setup as an example. They may have like a Kubernetes cluster or something rapidly changing, right? They're trying to be more fast-paced, things like that. And they need the load balancing from the north-south load balancer here. But it's got change control. So it takes like 10 days to do anything on this thing. And then, they say, okay, we need our own load balancer. Why? It's a CapEx expense, and it becomes a problem. With Snapt, they can easily just scale up as they need, deploy it, and they can just send some traffic to the Snapt device. That grows, right? And all of a sudden you've got 10 load balancers or 20 or 30 because you start to have load balancers for services as opposed to load balancers for businesses. So the other side of that where you see a problem is like you'll have an inbound load balancer that goes to your app service. They need to connect to a database. Do you get a second one for the database, or do you send the traffic back to the app server? back to the inbound load balancer to send to the database. And this becomes a problem in your firewall and with DMZ and security and PCI compliance and all this stuff. The ideal solution is to say, okay, cool, my database cluster is self-contained. It's got its own load balancer. My web service cluster is self-contained. And these things are all set up to be individual pods that you can move around. You can move it from one Kubernetes cluster to another. It's easy to test and to have a dev environment for them, but oftentimes it's cost prohibitive. So we solve that quite nicely, obviously, based on the fact that you pay for what you consume, essentially. So they wound up choosing Snapt because of a lot of the intelligence kind of monitoring and stuff of their services. So again, what are their reply rates, what's actually coming back. Snapt can also intercept replies, right? So because we're a full proxy, traditionally load balancers will say, okay, cool, I need to get to port 80. Let me check that port 80 is open. It is open. Let me check that port 80 gives me an HTTP reply. It does. Let me start sending traffic. But they don't monitor the replies. So we'll watch for the replies as well and say, well, hang on, this is a 500 error. Should we get this page from another server, for example? So you have this much higher kind of quality of service that you can ensure and be alerted if that happens, obviously. And then PCI compliance is a big thing. So things like being able to re-encrypt traffic after it's been manipulated and so on. The next case study, probably quite similar. Okay, global toy manufacturer, similar problem. They were moving from an infrastructure of having few devices to one of having many. Obviously, same kind of story, but also need very high level of support. And what's quite interesting is that they like to run everything on SUSE, depending on how you say it, the Linux distribution. And Snapt runs on any Linux. So that's why I'm sure you saw Red Hat as a partner of ours. We officially support running on Red Hat, SUSE, Ubuntu. There's a whole kind of laundry list of them, and you can really run it on anything. So it means you can run it in any custom cloud, any custom environment, and you can utilize what a lot of businesses have now is enterprise Red Hat support, for example. You can utilize that with partners with Red Hat, so we work together to get things fixed and so on. Why Snapt again? I think we've gone through this a lot, but like I mentioned, they're pure software, so just touching on that again, and a lot of the kind of post-install stuff, which I'll actually show you now, so that we don't need to hop on that, and what an implementation looks like. So this is the last thing before I just give you a quick preview of what it looks like. But it's quite quick implementation of Snapt, right? Because it's a software product. We do a demo, we do a pilot, POC, consultation and support around that. It's up and running, and the timeline is typically less than 30 days. So legitimately, you can get Snapt up and running in less than 5 minutes if you've got quick internet and you can download the image. But really, it's about that kind of flexibility and allowing people to move quite quickly. Yeah, I'm going to show you the product now, so I'll skip to the last slide where it says thank you, but I'll hold my thanks until you've seen the product. Let's see if I can get the right window open. Cool, it's quite squished with this screen, so excuse me if it's a bit of a weird aspect ratio. But everything is... I don't know I can actually show you what this password is. It's typed at the top there. In case I lost it. But the default one is admin. It's all managed through the web interface. So you've got, it has kind of compacted it to fit the screen a bit, so normally the stuff is next to each other, but it's all easy to use, easy to manage and work with and so on, and you configure it all through this, and it's modular, right? So you can see I've installed the balancer, GSLB, accelerator, and WAF, but these are all plugins, so you can have them all on one server, you can split them out to deal with your load or your environment, you can accelerate in the front, load balance in the back, whatever you need. And it's all web-based and easy to use, so you configure it all through here, and you get all your stats through here. And everything that you see can also be done by API. So anytime you see me show a stat or adding a server or anything like that, you can do it via API, right? So here you can see a small example. Like I said, it's a bit squished, but of average response times from the servers, how many 500 errors they've delivered, and so on. And you can use all of that data. So this is actually my favorite feature about Snapt. It's not the load balancer, it's just the data. Where you can say things like, okay, cool. If I ever have any 500 errors, then tell me. And when I say tell me, I mean you can tell it to tell you via Slack, via text message, via webhook, SNMP trap, whatever, on Sentry or whatever you're using to get your kind of alerts and logs, PagerDuty, whatever it might be. You can be told about it on there. So you can do simple things like say, well, if there's ever any 500 errors from our web service, tell me about it. But you can also do a lot of other stuff like response time. So you can say if the response time is ever over 400 milliseconds, then I want to know. or if anything changes, and you can also do the reverse. So what I like to do when I'm kind of advising clients is also to set the opposite, and that's to say if anything's ever less than. Because, for example, you might know that, okay, the site averages between 50 and 5,000 users. If there's ever less than 20, we've probably got a problem. So it's not only like a greater than, but a less than, obviously, that you can set up. And that lets you be quite proactive with picking up problems on the server. And because you can post webhooks for all of this, you can also pick that up on something else that you're doing, right? So you can accept this stuff via webhook and then trigger something else off. Like you might say, server response time's gone up. I need to notify my guys, but also I need to launch this or do that or run whatever, and so on. And because of the API, you can also post information to it. So you can mark that like if you want to do blue-green deployments, so you want to drain a server or bring another one up or anything, you can automate all of that. But so you've got the balancer, the GSLB, the accelerator, and the WAF. It's all easy to configure, easy to use. There's a lot of stats, and you get reporting for all of this. And like I said, you can get the stats via API as well. So you can have your stuff like monitor, not just if a site's up, but you can query what's the response time on your web servers, and how many 400 and 500 errors, or how many 100s, and whatever you're getting from them. You can, the accelerator is the same, and the WAF is the same. The WAF, I like to touch on a bit because it's quite different from traditional WAFs. A lot of the time, a solution like Snapt is sitting behind something like Cloudflare, a CDN, right? Which is providing you like a more traditional type of WAF. They're providing distributed denial of service prevention, for example, is the first thing. If someone sends 100 gigabits of data to your network, they have to block it up with the upstream provider. But what about the stuff they don't block, right? So a good example is like, if I go to your website and I notice that the login page takes a little bit longer, or the page that lists the product takes a bit longer, something like that. There's some component of your website is like abnormal to the rest of your site. Typically, it will be something that's querying the database. So maybe when I go to the page for products and I drop the filter down and I say, okay, well, show me 1,000 products on this page, I notice that the page takes 2 or 3 times longer. Probably, from my home, I can bring your site offline by just sending 1,000 requests to that page every second, loading the database, and the site comes offline. But it's not that much traffic, right? It's one guy's fiber connection. So it's not going to get blocked at an upstream provider. It's not going to get picked up as a normal. That's really where we try to focus in. If someone is not attacking you because they're attacking everyone, but they're actually attacking you very specifically, right? And that's what we try to prevent. So through things like intelligent rate limiting, the ability to blacklist, whitelist IPs, countries, things like that, the layer 7 firewall, and then the layer 7 firewall as well can be set to a very restrictive mode where it's basically default block, and you can train it what it should allow. So you can say on on a very important piece of your site, like, okay, log everything, I'm going to allow the stuff I want to allow, and then literally anything else you should block. So if the cookie doesn't match, if there's different arguments in the request string, whatever, you can block off, right? So it allows you to be really specific about how you protect the site. And instead of relying on a list of, say, 10 million rule sets of what suspicious queries look like, instead you can say, well, these are actually just the appropriate queries, the things that we should allow. And then if there's like an O-Day or something that you don't know about that's a threat on your site, obviously there's a good chance that you're able to block it here as a last resort if it gets through your upstream provider. The accelerator we mentioned a lot, about the performance and stuff like that. The GSLB obviously as well. And then the balancer you have, what I'll show you quickly is just kind of how easy it is to kind of edit and control things, but you can see it's all listed here. You can put on your HTTP checks and set it to what you want to get, and it's very easy to use, right? So there's a lot of documents, videos, and stuff as well where you can pick it all up if you need, and then a lot of visibility. So your latency and your throughput and your sessions, and you can live graph all of this and put it up on a monitor, and there's all views for that and so on, because that's what's become very important to DevOps, is like the state of the application as opposed to the availability of the application, I think, and the performance of it, especially as, like I mentioned to you, there's such a lot of pressure now around page loading times and website performance and speed and so on, that it's very important. So yeah, if I was to summarize that, we try to make it easy to use in terms of not being simple, but rather that anyone that's got a tech background can deploy and run the thing, and also that it's easy to use within your business. It's easy to license and deploy and spin up and put in your environment. We try and make it add a lot of value after installation. So that's something that I think people that are looking at solutions like that should really be thinking of is, how much telemetry can you get from this thing? How easy can you integrate it into your kind of process and so on? We try to make it very modular and flexible and easy to customize and easy to do various things with and so on. And that's really the difference. There's features in Snapt that people don't have, and there's more information and health checks and so on. But to me, it's not about like box checking, this 1,000 features and this 1,000 features on this RFP, as much as it is about saying, is how enabling is it of kind of that DevOps cycle and process and what they look for and what they need in order to keep this platform running as smooth as possible. And that's where we focus. So we do a lot of work with clients. We work with them very closely. Our support, so one of the big things, a critical component to kind of building Snapt is having very good support. And the reason for that is kind of selfish. Obviously we want to provide good support to our clients. We also want to work very closely with our clients. So clients often have a heavy hand in what we deliver next and what features are needed and stuff like that. So we have a lot of interaction with clients. We don't have outsourced support to anything. It's always direct with Snapt that people deal. And yeah, that's kind of, that's my opinion of why Snapt is great to use, and I guess what the kind of DevOps market needs to be looking for in ADC. Yeah. Am I doing questions? Yeah. If anyone does have any questions other than the password, which I'll just email to you. I think it's actually recorded, that password, so I better tell someone to change it. Yeah. If anyone's got questions, please ask. And I don't have my glasses, so just go for it.
I actually have two questions. The one question is, does the Snapt integrate into a SIEM solution, like, for example, Splunk? The second question is your GSLB. Is that similar to what, like, the info blocks and protecting DNS, or is just a speed up in that sense?
Yes, you can send the data. You can send everything to Splunk, and you can also, with Snapt, you can do what we call HTTP logging, where it will output like what you would expect to see from like an Apache log or an IIS log, like what the web request was and everything, but along with response times, what the queue was, how many active users were, etc. on the end, and you can ship all that stuff off. And the GSLB, so the GSLB is at its most basic is a DNS server. It's saying, I want to go to www.snapt.net, and we're saying, well, here are the IP addresses for that. What it's really doing behind the scenes is saying, well, where are you from? Do I need to respond to you differently depending on who you are? And secondly, where am I sending you? Is that online? So it does health checks of your web servers and stuff like that, and will only send users to that place if they're responding quickly and if they're the most appropriate place, like US people to go to their local geography and Europeans people to go to theirs. But with all things being equal, everything being online, it's just responding to DNS queries.